All right, welcome back. Hononegah Honors, Algebra 2. Section 13.4 is our last conic. It's hyperbolas. It looks a little bit like two parabolas. It's not quite that shape, but a hyperbola is a set of all points in a plane such that the absolute value of the difference of the distances are fixed. Let's go through that, and I'm going to make up a number here. Let's say I have a fixed distance, a fixed difference of 30. What that means is every single point, if I take one distance minus the other distance, will be a 30. So if this is 40 and that's 10, would be an example. So every single time, so no matter where I go, so let's say I go further this direction, so I go like 45, then this distance would be 15. So again, it's a fixed difference of the two distances. So that is the opposite of an elliptical shape. So notice if you kind of took the two and put them back towards each other, that would be an elliptical shape. And so instead of having a fixed difference that's an addition, it would be a fixed difference that is a subtraction. And you can actually calculate what that fixed distance would be in every hyperbola, but that is not something that we actually talk about as we get into hyperbolas here. Now, we still have foci points, okay? So we have that point here and that point here would be the two foci points that we use for our constants. So here's what the equations would look like, and here's all the different things, and some of you are going to look at this and say, wow, there's a lot of stuff. So the vertices of the hyperbola are the points of each curve in the hyperbola. There are two axes, the transverse axis and then what's called the conjugate axis are perpendicular to each other. So now, we don't really talk much about the transverse and conjugate axis. Basically, we talk about does the hyperbolas go left and right, or does the hyperbolas go up and down? So they're still going to have a center. So they're still going to have a center. You're still going to have two vertices, and then you're going to have two foci points. And this box, I always refer to it as an asymptotal box, but that box is created, and then the diagonals of the box make the asymptotes. And so we're going to be writing the equation for the asymptotes. And that's going to be a little bit challenging for some people, but here we go. Standard form for a hyperbola. In elliptical shape, it matters which one's bigger. In a hyperbola, it matters which one is first. So you'll still have this x minus h and y minus k. So that still is our center of our hyperbola. It's a matter of which one comes first. If the x value comes first, then you're talking about a hyperbola that goes left and right. If the y value comes first, now you're talking about a hyperbola that goes up and down. So the vertices, notice that the vertices you're adding with x, and on this hyperbola you're adding with y. So you're always going to be looking at what comes first more so than what is bigger. And then the foci points again has a c value, and that c equation changes. In an elliptical shape, it's a minus b squared. In a hyperbola, it's a squared plus b squared because it has to be on the outside of the vertices. So lots of things going on here that you're going to need to be concerned about. Next, the equation, remember when you had a line, so y minus y equals slope parentheses x minus x, when you're trying to write an equation of a line given a point and a slope. So you're going to write an equation of a line given the center, and then the slope will always be the y value over the x value. So whatever value is under y compared to whatever value is under x, because it's rise over run. And when I say that, I mean it's the b value over the a value, not b squared. So lots of numbers to worry about in this one. So here we go. Center, there's lots of questions we got to answer now. Center, vertices, foci, and equation of asymptotes. Let's graph this one first. So the center's at 0, 0, and I'm going to show you how to graph this. It's very similar in the beginning to how you did an elliptical shape. You got a center at 0, 0. What's under x is a 2 or 4, so I'm going to go 2 to the right and 2 to the left. Remember, it's the square root of that, so I'm going to go up 4 and down 4. Now, in an elliptical shape, you would connect those points. In a hyperbola, This is what creates your box. So those 4 points create your box. Then draw in the diagonals through the box. Those are your asymptotes. Now, which direction will this hyperbola go? This hyperbola has an x value first. So notice that x comes first. So therefore, the touching the box along the asymptotes, touching the box along the asymptotes. So that touching the box is your vertice points. Here's what I would tell everybody. Take your center and add and subtract however much you went left and right. Now, because these are all integers, I would go ahead and write this as -2, 0, and +2, 0. If that was not an integer, I would leave it as the square root of whatever number. So again, just like with a circle that or just like an elliptical shape that has basically how far am I going to go left and right as a radius left and right, how far am I going to go up and down as a radius going up and down, and it's always the square root of that number, just like radius. Next, I want foci. In order to do the foci, I need c. C squared is equal to a squared plus b squared. So I'm going to add those two together. So 16 plus 4 is 20. Square root. So plus or minus the square root of 20, which is 2 square roots of 5. The question becomes, do I add it with x or do I add it with y? Remember, this is a left and right hyperbola, so I'm going to add and subtract the c value to the x of the center. So notice the vertices, you're going to add the a value, and the foci, you're going to add the c value to the center. And the last thing is the equation of the axis of symmetry. It's y minus the y of the center plus or minus. Now, you went up and down 4, left and right 2. So your slope is 2, and then x minus 0. Now, you don't always have to do 0, but I'm putting it in there just to show you where you would put the center when doing your hyperbola. Center, foci, vertices. I probably did this out of order. And equation of asymptotes. Center, be careful. The x value is -5 and the y value is 3. So it matters which parenthesis you're looking at. The x parenthesis is a -5 and the y parenthesis is a +3. And it's the opposite of what's in there. So the center of this is at -5, 3. Now, how far do I go up and down? I go up and down 3, and notice that is the number that comes first in the equation. I go left and right 2. That creates my asymptotal box, of which the diagonals are asymptotes. Y comes first in the equation, so it touches the box, and those 2 points will be my vertice points. So when I do my vertices, I'm going to start off at -5, 3, and I'm going to add and subtract 3 because that comes first. Again, usually if I get integers, I go ahead and add and subtract. So I get -5, 6 and -5, 0 are my 2 vertices. You can go to the equation of the axis of symmetry next, but the foci you're going to need c. So it's y minus the y of the center plus and minus. Now the slope, under y is a 9, so that's 3 up and down. Left and right, or under x is a 4, so left and right 2. And then x minus -5. C squared equals a squared plus b squared. So I end up getting the square root of 13. So I'm going to add that with the y value of the center. Next is as hard as this gets. So now I want to complete the square with the x's. I want to complete the square with the y's. So I'm going to add 3 squared to get my completed square. I need to take out a -2 first. So I'm going to add 5 squared. But on the other side of the problem, I don't add 5 squared. I add 5 squared, whoops, plus 9, or 3 squared, minus 50. because I had 5 squared times negative 2. So I end up getting 4. Just like with the elliptical shape, everything equals 1. So I'm going to divide everything through by 4. So x plus 3 quantity squared over 4. Y minus 5 quantity squared over 2 equals 1. So there is the equation that I want to do. So my center is at negative 3 for x, positive 5 for y. Left and right 2, and that comes first. That matters. Up and down the square root of 2. So I'm going to go a little box here, a little over 1. Diagonals. And it goes left and right because the x comes first. It touches the box going left and right. So my vertice points, I went left and right 2. So negative 3 plus and minus 2, 5. So if I add 2, I get negative 1, 5. And if I subtract 2, I get negative 5, 5. So those are my 2 vertice points. Foci, I need c. C squared equals a squared plus b squared. So c squared equals 6. So the square root of 6. And I'm going to add that with my x of my center. And then the last thing that I need is the equation of the asymptotes. So y minus 5, because that is the y of the center, plus and minus. Now, this one's not very nice. Square root of 2 is my up and down. 2 is my left and right. So that at least the radical was on the top. X minus negative 3. Last example of the day. I'm going to go 9y squared. I would go ahead and hit pause on this one. See if you can do this one by yourself. All right, we'll keep going. I'm going to take a 9 out of the y's. Half of 2 would be 1 squared times the number in front makes a positive 9. So that is how I completed the square with y. I'm going to take a negative 4. Half of 4 would be 2 squared times the number in front would be negative 16. And so I add all that up, I end up getting 36. Dividing everything by 36. Oops, that's an x. And there's my equation. So the center is the first thing that I need, and notice the x value is the second one and the y value is the first one. That's going to matter. So negative 2, negative 1 is my center. My up and down is 2. My left and right is 3. That will create my asymptotal box. And again, what comes first matters because after I draw in my asymptotes, the actual hyperbola goes up and down from this because the y comes first in the question. So my vertice points will be 2 on the y. So my vertice points I will add 2 and I will subtract 2. So I went ahead and just did that just for space purposes, but I added, subtracted 2 for my 2 vertice points. C squared equals a squared plus b squared. So I end up getting plus and minus the square root of 13. And again, I'm going to add that with the y value of the center to get my vertice points because that is on the transverse axis. That's the axis of which the foci points exist. Writing the equation is the last thing, and I know the bell is ringing here, but I'm going to go ahead and do this. Y minus 1. Now, how much did I go up and down? How much did I go left and right? Remember, it's rise over run, and then x minus a negative 2. So again, writing the equation using point slope form. All right, sorry if there was a glitch right here. I had to stop and then start the video. So next, we're going to find the equation of a hyperbola at the origin, given the focal point at 0, 7 and a vertex at 0, 3. So I would make myself a little sketch here. And of course, we had an issue. Make myself a little sketch here. So my center is at 0, 0. Focal point at 0, 7. So up here is one of the foci points. That actually means the other foci point is down here as well. And then the vertex at 0, 3, and a vertex at 0, -3 then. So I'm going to make my asymptotal box here just to kind of give myself a picture. And there is the hyperbola. So here we go. Y value would have to come first because it's an up and down hyperbola. So you're talking about y squared and x squared. And then how far did the box go left and right, and how far did the box go up and down? Now, I understand it went up and down 3. That's easy. But under the x is a little more complicated. Now, c squared equals a squared plus b squared. I know the c value because the focal points are 7. So we're talking about 7 squared would equal, and then I know one of the values is 9, and I just don't know the other one. So 49 would equal 9 plus b squared. Subtract 9. B would have to be 40 in order to create a C value of 7 and the vertices that are 3 up and down. There's only one video for this particular section, so 13.4 part 1 and 13.4 part 2. So just practicing, extra day of practice. If you have any questions, make sure you talk to your teacher, and good luck.